always forget to record, and then one of my co-leaders reminds me, but neither of them are here tonight. But so we're recording. Yes. All right. All yours.
Okay. Yeah, it's going to take me a second because I want to make sure I check one box to share computer sound. I'll be using that in my demo. I'm just trying to figure out how do I, yeah, got it. Can you guys see my screen?
Yep.
All right. Okay. So yeah, so before we start, I know a lot of folks here, we were discussing graph database, Neptune, and GraphQL, etc., Neo4j. So my presentation today, it is basically, it's going to use graph database, which is Neptune, Amazon Neptune, as one of its services, but there are other services too. And I'm going to get into the details of it. So it's not just Neptune focused. I just wanted to clarify it before we start our presentation and the demo too. All right, so I just have a small PPT here. It's just really for my talking points and my guidance. It has an architecture diagram, and I would love to walk through that architecture diagram. I think, Brian, you have already shared it in the meetup. And once we are done with going through the services and the use case that I'm going to talk about today, I do have a small demo which is created in my own AWS account. However, there is a blog that was published last year for this same use case, and that has a cloud formation template. So if anybody wants to, if they want to deploy it in their own account, they can always do that. Let me just start my. All right, so I think Brian already introduced me. I am my name is Vijay. I'm a solutions architect working with AWS for past 2 years. I'm based in Boston. Prior to AWS, I used to work with CVS and other retail companies. So my experience mainly into IT is mainly into retail and healthcare domain. I have been working with IT or IT industry for around 18 years. So today, the use case or the blog that I published, it is related to healthcare industry, a specific use case of the healthcare industry, which is called adverse events. Adverse events is basically nothing but it is whenever there are clinical trials in the healthcare industry, whenever there is a new product in market, a new drug, for example, COVID vaccine, like the latest and greatest example can be COVID. So the vaccine that came in, any clinical trials or any new drugs that get manufactured in pharmaceutical industry, it is very critical to know for the manufacturer, it is very critical to know if there are any side effects of the drug. So whenever the doctors prescribe that drug or that particular medicine to its patient, they want to monitor it very closely. What are the side effects of that medicine? And if there are any, it is very critical that these side effects get reported in a timely manner because there are a lot of regulation, and this timely manner is very critical for the safety of the patient, safety of even the product safety. Adverse event is nothing but it is the adverse event, or it is the adverse reaction to the product, to the medicine, or to any clinical trials or any new drug. Now, this is a very classic problem, very time-sensitive issue, and the challenges that we usually face with adverse event detection is that usually in a clinical trial, like around, let's say, like, and these numbers that I have put in here are based on some average, like some statistics that I found on some of the papers. So it could vary there is a tolerance to the number, but it could vary little. So usually for a clinical trial, there are close to 5,000 patients who sign up for a drug therapy. And on an average basis, there are 100 cases that get reported from various sources every day for a particular drug. Now, these sources could be, it could be patient calling the nurse or patient calling the doctor's office. It could be if that particular patient is enrolled in a patient support program, then he's calling the number that has been given to him or any type of a helpline. It could be email to the doctor, it could be fax. So basically the gist of the story is that these reports, the adverse events, can be reported from various disparate sources, and the data can be very unstructured. It could come in various formats. If it is done totally manually, let's say that we have like a man force, or we have people who is doing this job, it could get very tedious based on the volume of the data. It could be error prone because let's say like you have to go through every email. You have to, looking at the contents of the email, you have to figure out if this person really is having like adverse symptoms, and then you need to flag it as an adverse event, which can get very tedious. It could get manual. Since it is manual, it could be error prone too. Another challenge in detection of adverse event could be the data can be unstructured. It could be, sometimes it could be facts. It can come in form of images. Sometimes it could be email, like I said. Sometimes it could be call. There could be spelling mistakes, etc. Now, what we're going to talk about today is that how AI-based services. So the main focus is how AI-based services help us solve this issue. And we are also using Neptune as the graph database to fetch data to solve this issue. So let's talk about, I'm going to go in my next slide. And any questions so far? If I'm going too fast, I just want to address any questions before I leave the slide. I think everybody's all set. Okay. So I think I'm just, okay. So that's basically the problem definition. Let's see how AI-based services can help us solve this problem. Typical benefits of the services are we are automating the process. We are automating detection of adverse event. And in a few slides, I'm going to talk about what are the services that we can use to automate this detection. That increases our productivity. These are very typical benefits. Since the process is automated, it is more accurate. It is less error.
BJ, if I could say, it's getting a little hard to hear you.
Okay. I'm just tightening my headphone. Is it any better? Any better?
No,
it just sounds like you're distant to the microphone.
How about any better?
It was good for a moment, and then
okay. Let me just check this setting.
if you bring your mic closer to you.
Yeah, I have my headphones on. Any better now? Or
yeah,
That's
that's
a lot
good.
better.
That's good. Yeah.
okay. Okay.
I think it's getting tucked behind your hair, maybe.
Yeah, let's see. All right. So far everyone is with me, right? Let me know if you can't hear. I'll change my my microphone. So basically, let's see how we can solve this problem using AI-based services, and what are the typical benefits of using AI services rather than doing it manually. The first benefit is since we are automating the process, we are increasing the efficiency, we are increasing the scalability. If the volume increases, we are still good. Our system can handle it. We are increasing the productivity, and we are also increasing the accuracy. accuracy. Being said that, it doesn't mean that we are replacing the manual workforce. There are still instances, even if we use AI services, they are not accurate all the time. There is something called a confidence score. And that's something that we need to use to determine how accurate the output is. And based on that, we can always program it to be reviewed manually by like a human review, just to make sure the data that is getting sent is 100% accurate. So in today's, the use case that I'm going to showcase today, I'm going to use call as the input data. So basically, if I mean, I know it's not possible here. If we were in person, I could have demonstrated the actual patient patient and nurse interaction, where somebody just goes outside the room, makes a call to a given number, and then that call actually gets recorded. And how do we see that? How do we detect adverse event based on that call? Since we are totally virtual, what I've done is I do have a recording of such call, and I'm going to upload this recording in my demo to S3 bucket, and then show from there how it gets triggered, how the processes gets triggered, and how we actually detect adverse event, and how we can visualize it in Kibana. So I'm just quickly going to go through the services that we are using. Now, even though this particular use case uses only call recording, call as the source, this can always be extended to email. It can be extended to fax. Basically, what we need to make sure is that everything, all the sources that we are using, the data gets converted to text in the end. And once it gets converted to the text, then the process after that, it will be very similar. Actually, the same process, same lambda functions can be used to process the data. Going on to the next slide. All right, so the first service that is being used, the AWS service, is Amazon Connect. It's not necessary that we need Amazon Connect, just because this is something I have developed from scratch. This was used as a call center solution. So this service actually provides, Amazon Connect is basically call center solution, cloud-based call center solution that is provided by AWS. If a particular company, if you already have another call center solution, then all we have to do is upload that recording into S3 bucket to trigger this workflow. S3 storage, S3 is nothing but simple storage service. It is the object storage service that AWS provides that has been used for storing the data. Third one is Amazon Transcribe. It's a fully managed and it's a continuously trained automatic speech recognition service. So basically this converts your audio to text, your speech to text, and this has been used in this particular use case. The fourth and most important service for the use case is Comprehend Medical. Comprehend Medical is a natural language processing service which makes use of machine learning to extract the medical information. So this is the service that extracts any named entity, any relationship. It extracts the symptoms, it extracts the diagnosis from the text or the unstructured data. This comes inbuilt with ICD-10 and RX norm. These are the ontologies that are already supported by the service, and you can also use your custom. You can also create your custom classification. This is just an example of how it looks on the console. So Comprehend Medical provides like a real-time analysis, and you can see that on the left-hand side, there is some text. It's a text, and anybody can test this. Like if you have a AWS account and you go to Comprehend Medical Service, this is kind of a sample text that you have. And on the right-hand side, you can see that it detects any dosage, brand name of the medication. It detects any named entities. It detects any diagnosis and symptoms. All these are detected automatically by Comprehend Medical. Elasticsearch is used for storing data, and Kibana is the integration. It's a visualization that is very tightly integrated with Elasticsearch. So that's another service that's being used. And last but not the least, Neptune graph database. So where exactly, I know a lot of people in the audience are interested in GraphQL and graph databases. So where exactly this has been used is to store the ontologies. The one that is being used in this particular use case is MedDRA, which is needed for adverse event detection. If you my blog already has steps how we can load. So all the ontologies, they were downloaded from UMLS site, and they were I had loaded only selected. I loaded MedDRA, but all the ontologies can be loaded in this graph database. And where the graph database is becomes a benefit is that all of them are, they have relationship with each other. And if you know, let's say that you have like a preferred name of one, you can just get relationships of all of them using, in my example, I have used SparkQL. So literally queried my database using SparkQL. So that's the advantage of having a graph database where you can get relationships and how they are related between like different ontologies, and you can get different information using GraphQL. Any questions so far before I walk through the architecture diagram? Good.
Actually, I have a question. Uh, you said that there was you had a cloud formation for this. I used Connect about a year ago, and at that point, it didn't have very good cloud formation support. I assume by now that has improved.
That definitely has improved. Yeah. Yes.
Okay. Yeah. Connect was a great
So, yeah. Have you looked into? So there is AWS provides something called Quick Start. Have you looked into the Quick Start for Connect?
No, I was working with Connect at a company, and then they had pandemic layoff, so it became moot for me. But I'm just curious. And you'll probably dive into it, but I don't know. So interesting. You mentioned that either Transcribe or Comprehend could deal with protected health information. If there's a chance, if you could say more about that, that would be interesting as well, because I work at a medical company, so that's
sure.
Our bread and butter. But
absolutely,
as you get to it.
Yeah. So we can do it while going through the architecture diagram, because I know being into a medical field, HIPAA eligibility and PHI will become like it utmost important. So this is the architecture diagram for this particular use case. So, and it is numbered, so it just tells us what the different steps are. So step one is, I wish we were in person and we could actually demonstrate a call, but maybe some other time. Step one is actually a patient calls nurse on a given number. So folks who haven't used Amazon Connect, it's a call center solution. Once you configure Amazon Connect, you get a number and you can call on that number, and it works like any other call center. So once I configured this in my account, I do get a number that you can call on. So let's say, so this is kind of a pretend case of patient is calling the nurse and nurse is picking up the call. So agent will pick up the call in step one. Once the call is over, and the patient has reported. So probably I have a script that I'm going to share once we walk through this architecture, and I'm going to play the recording too. So once patient hangs up the phone, both the parties, they hang up the phone, the recording of this call, it gets stored in Amazon S3. Once the recording gets stored, so S3 can have a trigger event. You can have an event trigger where you can configure it to say that if as soon as the object is stored in S3, you want to kick off a Lambda function. So in this case, once your recording gets stored in Amazon S3, a Lambda function is kicked off. It's a step function that we are using. So step function is nothing but it's a series of, it's a function. It's a step function is a function where you can create your own workflow. And this particular workflow basically is going to call series of Lambda functions. Now, in this step 2, like I said, we are using a call recording here. However, this could be email, this could be fax, this could be plain text, and based on whatever the input is, we need to convert it to, before it goes to comprehend medical, it has to be converted into text. So doesn't matter where your source is coming, what is the source of your input, doesn't matter what format it is in. If it once it is converted to text, anything that is 3.1 onwards, the process is exactly same. So in this case, once the step functions are kicked off, the first step is where your recording, which is in your speech, that is going to be converted into the text, and it is passed on to comprehend medical. Once it is passed on to comprehend medical, it's going to detect the medical entities into your data or the text, and then it goes to step 3.2. Now, what step 3.2 does is comprehend medical. If let's say that if patient says that I am anxious or I have fever, what comprehend medical is trying to do is it's going to detect that word, and that will go into step 3.2. What the step 3.2 is going to do is it is going to iterate through these entities that are detected by comprehend medical, and it will try to match it against Neptune database, and it will get more information about that entity from Neptune. So for example, if fever is the entity that was detected, then it will go against the Neptune, where we have already stored the MedDRA ontology. It will try to get the actual preferred name for fever. It will try to get the ICD code for fever, and then bring back that information. It will get the medical term for fever, and bring that information back and add it to the data in step 3.2. And the format of the data in every step, it's a JSON. So very simple to manipulate the data. Now, based on what it finds in step 3.2, it will flag this particular data, whether does it have an adverse event, yes or no. And if it has an adverse event, so regardless of whether it is adverse event or no, the data will get stored in Elasticsearch, and then it can be visualized in Kibana. Now, the way this can be extended further is what I've done is really there is a Boolean flag, and if the data has adverse event, then we are just making that particular is adverse event true. If it is not, then we are just making it false. Now, this can be extended further, like we talked earlier. It's very important to report the adverse event in a timely manner because of the regulations. And this data can be extended to send it back to FDA or to send it back to product manufacturer, the pharmaceutical company, etc. So really, or let's say you want to send email, any way you want to process this data, it can be done based on whether it does have an adverse event or not. So that's really the architectural walkthrough. Brian, to answer your question about PHI, Amazon Comprehend Medical, since it deals with PHI and it deals with sensitive data, there is a way you can. So in my particular use case, I have omitted all the PHI data because there is a way you can. So this is all API based. The APIs are provided, and you just have to call the APIs, and there is a API where you can say not to include PHI entities. So it just adds entities that are non-PHI. There is also very often customers ask us how secure it is because you are using our data to train your models, and how do we know that that our data is not stored. So Amazon Comprehend does not store the data for training the model. We have models that are out of the box, and we also have an option. I'll have to check whether it is for transcribe or it is for Comprehend Medical. We do have an option where you can actually make a service request or a support ticket where you say that I want to opt out of storing the data, and your data will not be stored on AWS infrastructure. So those are two ways to secure it. And anything that goes in S3. So for this use case, the output of transcribe goes into S3 bucket, and but that is encrypted. So again, so it's pretty secure. And output of Comprehend Medical, it is not stored anywhere. It is very much on the fly, directly passed to the Lambda function. So really, you're feeding output of previous process to as an input to the next process. The only thing that gets stored is output of transcribe medical. Output of Amazon transcribe, and that is secured in S3. You always have an option to encrypt it. We also have something called transcribe medical. That service actually came out after this was built, but that is even more relevant to this use case where it can detect the medical entities out of the speech. So instead of using Amazon transcribe, we can also use Amazon transcribe medical. Any questions? Good. Okay. Hold on. Sorry about this. Okay. So I think it's a demo time. Unless anybody has any questions, I am ready to go to the demo part of it. I'm just going to walk you guys through what I have here, and all right. So so this is my this is the S3 bucket that I'm talking about, I've mentioned. We are not using the Amazon Connect here. We are I'm going to directly upload my recording into this S3 bucket. Before uploading the recording, I want to actually play the recording. I'm just trying to see how I can minimize this. Yeah. Before uploading the recording, I just want to play the recording and show you what script that. So this is a script that's used for the demo. It's literally this recording, and so basically, agent is nothing but a nurse. Patient is the patient who is calling, and there are few entities here which are detected by Comprehend Medical, and there are few words like, for example, dizzy, bloated, anxious. Then there is something called fever.
You're fading again.
Fading again. Any better now? No. How about now?
Yes.
Okay. All right. Sorry about it. So this is really the script that is used. I'm going to minimize the script, and I'm going to play the recording, and I hope you can hear the recording well. I'll just kind of fast forward it, play it quickly. Hello. I'm Agent and calling.
This is John. I started taking my medication repertoire last week, and I think I'm feeling a bit different. I wanted to confirm my symptoms and also report my feelings.
Absolutely.
Jen.
Sure. Can I have your full name, please?
John Kelly,
Sure. And can I also have your date of birth for security reasons?
October 1st, 1965.
Thanks for your information. Can you please describe your symptoms?
Well, ever since I started taking my medication, I have headache and fever.
Sorry to hear that. Anything else that is different?
I also feel a bit dizzy, bloated, and anxious.
Anxious. Okay, got it. Okay. Thank you for the information. I have opened a case for you. Our trained nurse will reach out to you in next 30 minutes. Just to confirm, you have headache, fever, and you feel a bit dizzy, bloated, and have anxiety. Please wait for nurse to get in touch with you. Thank you for calling Octank Healthcare. Is there anything else I can help you with?
That will be all for today. Thanks.
Thank you. I hope you feel better.
I hope you guys could hear it.
Yes.
Okay, great. All right. So what I'm going to do is I'm going to upload that. So that's the one that's a legit recording, and I have one more file which is I've just talked some gibberish. So just to show that how we are flagging adverse and non-adverse events. So these are the two recordings that I'm going to upload to S3. This would be exact same effect if we have like let's say we are calling into and then the phone is hung up. Exact same thing will get uploaded into S3. So once this gets uploaded, what happens is it triggers a step function. So this is already set up and this is part of the cloud formation. So if you guys use the cloud formation, this will automatically get created. It triggers a step function flow. Since I uploaded two files, it's going to have two functions, and it's interesting. So shows inside. It really calls series of. This is how step functions look like. It calls series of lambda function, and you can see it's really like a workflow. So the first thing is a transcribe audio job. Once that's complete, it will call comprehend, uh, medical comprehend. Comprehend, I didn't cover it in this, but comprehend is used, Amazon comprehend is used for sentiment analysis. So you can also detect if the patient was happy, sad, upset, that sentiment, whether he had a positive or a negative sentiment, that can be determined from the input too. So after comprehend, medical comprehend gets called. After that, detect AE gets called, which actually makes a call to the Neptune. And once it makes the call to Neptune, it actually flags the data, whether it has adverse event or it doesn't. At the end, it populates the data in Elasticsearch, and that's basically end of the flow. So everything went okay. Everything looks green here. What I'm going to do now is go to Kibana. Let's see. This looks good. So I was just testing it before the demo. Let's do last 15 minutes. And that's how it's pretty much near real time. So this is the data that we just uploaded, and as we can see, so this is a Kibana dashboard, very easy to configure. I have done few graphs here. The first one is a word cloud. It basically it this is going to present all the entities that are detected by comprehend medical. This is a simple pie chart where it's just going to give us percentage of. So we have 50-50 now. We have 2 records in total. One is where we heard the recording, where we flagged it as AE review is required, and the second one is where AE review is not required. And then this is a tabular format, and this is there is no development here. It is just like something that comes out of the box, and I have just kind of consolidated this into a dashboard. This comes, Kibana provides us this feature where you can present it in a different format. So this is the actual data. This is the actual JSON that gets stored, and you can see this also detects the sentiment, which is neutral at this time. And if you are interested in knowing what is the output of how did we get data from graph database, that's what I'm going to show. So this is the data that came from graph. I use SparkQL here. So like I said, for every entity that was detected by Comprehend Medical, this was fetched from graph database. It's basically that SPO, and I'm not an expert in graph. I really learned how to query the database using SparkQL literally for this use case. But I have done some basic querying here, that where you say you call the SPO. That's exactly what I'm calling. So this all comes from what I have loaded in the Neptune database, and this is all I downloaded, what they call as UMLS database, and I populated into the graph database. So UMLS is the official database. It's the data dictionary for all the medical entities. So what this does is, for every entity that has been, as you can see, every entity that has been identified by Comprehend Medical, it gets detail for it from the Neptune database, and it adds it here. So all the relationship can be populated. If you want to extend it, all the relationships can be populated, and then they can be fetched here. So if you look at this, just query this. This is publicly available. So this is how it's going to look like once you, this is something that's available publicly. So it's based on what entity you have fetched. So this is how it looks like. Right. That's pretty much it. And this, if anybody wants to use it, it can be further extended. Once you have flagged your data, that can be further extended to process it. If you want to email it, if you want to put it in a, like, for example, one of the use cases that we had thought about in one of my previous companies, that once you flag this data, it literally can go in a different queue, so that whoever is taking a look at it, they give it a priority versus the data that's not flagged. So that's how we can make it more efficient. That's pretty much my demo here. If anybody is interested, I can also show the Lambda functions that are used. Yeah. So these are all deployed using the cloud formation, which is part of the blog. So I have mostly used Node.js. Only for getting data from Neptune, I have used Python. So this is really the code for. This is literal. I've used SparkQL, some library that was open source library, that's what I used for it, and use SparkQL to query the data. So all the Lambda functions are pretty much here. These are the ones that get called in the step function. So every green box here is one Lambda function, except for where we are making a decision here. Everything is one Lambda function each, and they're all stored over here. That's pretty much it.
I'm really struck by how small the Lambda functions are. I mean, I've written a lot of lambdas, but these are, and I'll say I do Python, not Node, but these are quite small to be doing such interesting things.
That is, yeah. So the biggest, the lengthiest one is the Neptune one, and where I'm storing data in Elasticsearch. I think that is the lengthiest, because I think, Brian, one of the reasons why they are so small is the data itself is stored in S3. So not all the data, the transcribed data, and we are getting it from S3, and we are processing it, and literally output of one is going to the input, and these are all API based calls. So I can actually show the comprehend how that, I mean, it's like literally 2-line code to detect the medical entity, this particular one, where we are detecting the medical entity. It's literally it's literally like a 2-line.
Okay, and there's a question. Can you contrast why you use SparkQL versus Gremlin or Cypher?
Yeah, so I tried using Gremlin. I actually struggled with it with Node. So there was a technical issue that I had using Gremlin actually. What was happening was I tried Gremlin first and I tried with Node.js. Uh, the issue was when I was trying to iterate. So what I was doing in my code, what I'm doing is I'm taking an entity that was detected. Then I'm iterating through it and then taking that entity, going against the Neptune and grabbing the data. And there was an issue, some technical issue that I was facing when I tried to use Gremlin with Node.js. So because of that, I switched to Python because it was something to do with the iteration and not being able to pick up my latest entity. And then Python, I found it very easy to do that, the iteration process. So the issue with Node.js was related to that. If anybody is familiar with Node.js, it is the callback functions. That was the issue. I don't remember exactly what, but it was something to do with callback functions and that async await mode that was causing the issue to me. So that's the reason I switched to where you call in asynchronous mode. So I tried using async await in Node.js and I wasn't successful. It was still kind of not doing what I wanted to. So then I switched to Python just for this. And when I was doing my research, this SparkQL library was very handy. I tried couple of things and then this is the one that worked for me. So that's why I ended up using this.
Oh, great.
So this is literally one-liner code here to detect the entities. This comes with SDK. So Comprehend is a API that is provided by AWS SDK. And literally when you say detect entity, it's going to detect your data. And all I'm doing is concatenating, just appending it to my data and sending it to the next function.
That's great. Other questions people may have? Well, while people are thinking about questions, I was toying with doing something a little different for the giveaways. I noticed that we had some folks who identified as novices, and I'm wondering. Okay, I'll just be straight. I would like to give our two $50 cards to some novice folks to help start their journey. And everyone okay with that?
Yes.
Okay,
Sounds good.
awesome. And I don't know who said that they were novices, so I will tell a little story that my wife told me that she went when she was first starting out. She went to some personal growth workshop, and she was working in human services, and she was dirt poor, and she happened to go to a presentation on, personal growth something, and the presenter took out $100 bill and said, "Who wants $100?" And she said, "I do." And he gave it to her, and the lesson was, ask. So I'm just going to say, would any novice like a $50 Amazon credit? Just raise your hand or put your name in the chat.
Don't be shy.
Okay, Jenna, you get one. Absolutely. I got that's absolutely. This is what we do. I'm a community hero. This is what we do. We build community. One more. Eric, was that just a general yay, or do you want one?
That was a yay for Jenna. I don't need it.
Okay. So someone, yeah, some of us have lots of credits, but would someone else like one? $50. Go play with services without fear. Seriously, nobody? Okay, while people are trying to get off their courage, I'll say, Jenna, if you could send me an email, just briantarbox@gmail. I'll send you the code. Oh, come on. All right, you don't have to be a novice. Someone else must want a $50 card.
Sure.
Okay, great. Send an email and I'll send you one.
All right.
All right, excellent.
Thanks,
Yay.
Brian.
Yeah, this is how we do community. So I'll say our next meetup in 2 weeks, I believe it's going to be on Kubernetes, subject we haven't gone after for a while, but I've got to do a little paperwork. But if anybody would like to give a short talk, short introduction, whatever, Jenna, if in a few months, if you want to come back and tell us what you did with the credit, that would be awesome. This was a fascinating talk, I thought. And any other questions, comments for folks? Okay, awesome. Thanks for coming, and we'll see y'all in 2 weeks, and be safe.
And
Thank you so
Brian, quick
much.
question.
Thanks, Brian.
Yeah,
Will you
yeah.
be sharing the recording?
Yes, absolutely. Yeah, we'll post it in our Slack for the meetup, and I think we also do it on the meetup itself. But yep, absolutely.
Okay, great. Nice meeting you all.
All right, excellent. Thanks. Bye.